welcome back. Next video we will discuss the question number 9, and the question is, give algorithm to solve Tower of Hanoi problem. Show that the efficiency of this algorithm is an exponential. So here we are having two questions. So for Tower of Hanoi problem we have to write recursive algorithm. So the given question as, give a recursive algorithm to solve Tower of Hanoi, and we have to find the efficiency, and that efficiency is equals to the exponential value. Okay, let us just solve this problem. Solution. So now first tell me what is the meaning of Tower of Hanoi problem. Tower of Hanoi means, so simply just consider three towers. Just I will take a small example to explain this, because if I take a big example you people can't understand. So I will take three towers, A, B and C. And in these three towers I will place some of the discs. First on the above, one more on the above, one more. So first disc, second disc, third disc. So here we are having some rules that smaller disc always present on the larger disc. That means vice versa is not possible. You can't place third disc over second disc, so that is not at all present. I mean, that should not be there. So smaller disc or peg should be placed above the larger peg. So here we are having only two conditions. I will shift n minus 1. N means 3 discs. N minus 1, 2 discs. So first two discs from A to B by using of third tower. In the next step, from B to C by using of first tower. That's it. So how means, just see here. So first what I will do, I want to move from A to B. First n minus 1 tower, n minus 1 discs, right? So can I move 1 here? Yes, I can move. But can I move 2 to B again? So on the top of 1 I can't place 2. So first I will move this 1 from A to move disk 1 from A to C. Here I will move this first disk. Okay. So next what I will do, second disk I will move to B. Move disk 2 from A to B. That means second one will come here. Next, first disk I can place over 2. Yes. Move first disk from C to B. So here I can place 1. Yes, this is okay, no problem. So what it means here, move n minus 1 disks from A to B using C. Okay. So after movement, so your pegs will be, here we are having third, in der B we are having 2 and 1, and C is empty. So now what I will do, next stage, move disks n minus 1 disks from B to C just by making use of A. So what I will do, first I will move this third disk from A to C. Move peg 3 from A to C. So this disk will going to move to C, third one. Next, can I move 2 to C directly? No. So above 2 we are having 1. So I will making use of A. So first I will move first disk from B to A. Move disk 1 from B to A. I am using A tower, that's it. One will come here. Next one will goes off here. So if one is not there, how many pegs are there here? Disks? Second disk. So I will move this second disk from B to C. Move disk 2 from B to C. So now second disk will come here. So here no second now. Next, finally, first disk move from A to C. Move disk 1 from A to C. Now here it is not there. Here it will be there. 1. Yes. So what we did? Move n minus 1 disks from n minus 1 disks present in B to C by using of A. That's it. So finally this is the initial step. So these 3 disks are moved to here, A to C, by making use of B. So for this, so how to write algorithm, recursive algorithm? Algorithm should starts with name algorithm followed by space followed by name of the algorithm. For example, Tower of Hanoi, I will write like this: TOH parenthesis. Inside parenthesis I have to pass parameters. So n value I will pass. Next, tower A contains 3 pegs. Tower C, that means from A to C I want to move. This is my intention. From A to C I want to move by making use of B. So these are the parameters. Open. For example, if only one disk is there, no need of B, directly you can move from A to C. That's it. That is the initial condition. If n value is equals to 1, then just write a message, write move directly from A to C and just return from the function if n value is 1. Else means here we are having 3, so you have to making use of B or C to move the disks. Else what we did first, we are moving n minus 1 disks. That means by calling the same function return, calling the same function, how many disks you are moving? N minus 1 disks. Instead of n, you are moving now n minus 1 disks from A to B by making use of C. From this example I am telling this. From A to B by making use of C. Close this. Again you want to return, you have to return one more, that is don't write return, call the same function, that's enough because it is recursive. So Tower of Hanoi, so this is a move top n minus 1 disks from A to B using C. Now again call the same function. 2 times we have to call the function because again we are having move again n minus 1 disks from B to C by making use of A. How many disks? N minus 1 disks from B to C by making use of A. And close this and close your algorithm. Okay, so this is the algorithm. For this algorithm we have to find the efficiency. I mean, we have to find first recursive relation. Sorry. For that recursive relation we have to find the efficiency in terms of big O or theta. So first tell me, for example, this total algorithm takes time, consider t of n. Okay, next, this will execute if means only one time it will execute, as you people know, I discussed in the class. Next, how many times this will execute? If this execute n times, this will execute n minus 1 times. So what is the function? T of n minus 1 times this line will execute this instruction, and this instruction will execute again t of n minus 1 time. So just add that t of n is equals to 1 plus 2 t of n minus 1. So that is a relation. So t of n is equals to 2 t of n minus 1 plus 1. So this is the recurrence relation. Okay, so this is the algorithm to find the tower of Hanoi. So for this algorithm, so we return a recurrence relation. So t of n is equals to 1 plus 2 t of n minus 1. So if n greater than 0, if once n equal to 0, so your answer will be constant. Constant means you can use the class 1. So let us solve the recurrence relation now. So what is the recurrence relation? 1 is already solved, there is a constant. So we have to solve t of n is equals to 2 t of n minus 1 plus 1 to find the efficiency. So how to solve this recurrence relation now? So right hand side we have to solve. So what is the value of t of n minus 1? We don't know. So but we know the value of t of n. What is the value of t of n? 2 t n minus 1 plus 1. So what is the value of t of n minus 1 then? Therefore, so just substitute n minus 1 in place of n. What you will get? 2 t of n minus 1 minus 1, n minus 2 plus 1. So substitute in this equation. We can also use by substitution method. By using substitution method, is it visible? Okay, by using substitution method, so we are substituting t of n minus 1 in place of this. So what it will become? T of n is equals to 2. What is the value of t of n minus 1? 2 t of n minus 2 plus 1 plus 1. So what it will become? 2 square t of n minus 2 plus 2 plus 1, 3. Or if you want, you can write as it is 2 plus 1. Okay, no problem. That is the value of t of n. Again substitute. What is the value of t of n minus 2 here now? T of n minus 2 equals to, in place of n just substitute n minus 2. So 2 t of n minus 2 minus 1, n minus 3 plus 1. So back substitute this into this equation. We will get t of n is equals to 2 square as it is. Instead of t of n minus 2, 2 t of n minus 3 plus 1 plus 2 plus 1. So now just tell me, to 2 square into 2, 2 power 3 t of n minus 3 plus 2 power 2 plus 2 plus 1. So that is t of n. Again, what is the value of t of n minus 3? Is equals to 2 t of n minus 3 minus 1, n minus 4 plus 1. So substitute this into this equation. We will get t of n is equals to 2 cube as it is. Instead of t of n minus 3, 2 t of n minus 4 plus 1 plus 2 square plus 2 plus 1. So 2 power 3 into 2 power 4, t of n minus 4 plus 2 power 3 plus 2 power 2 plus 2 plus 1, t of n. Now repeat this step for k times. Repeat for k times. So this formula will becomes t of n is equals to, so instead of 4, that is k, t of n minus k plus 4, this is 3, k, this is k minus 1 plus 2 power k minus 2 plus so on plus 2 power 3 plus 2 power 2 plus 2 plus 1. Okay, so this is the formula. So now what you will do, so we know t of n, that is t of 0 value is 1, so this value should becomes 1 when we assume n minus k is equals to 0. So just I will assume n minus k is equals to 0. So can I write this as n is equals to k? Yes. So what I will do, just I will substitute in place of k n here. So what it will become, t of n is equals to 2 power n, in place of k I will substitute n, 2 power n t of n minus n plus 2 power n minus 1 plus 2 power n minus 2 plus so on up to 2 power 2 plus 2 plus 1. I am not written this, so just assume no paper for me. Now n gets cancelled, that is 2 power, I mean t of 0. What is the value of t of 0? 1. So I can write as 2 power n plus 2 power n minus 1 plus 2 power n minus 2 plus so on up to 2 power 2 plus 2 plus 1. So this is the final formula we got. Hence we solved efficiency will be in the order of big O or theta. You can take any one. Big O of, what is the highest degree here we are having? 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power n minus 2, 2 power n minus 1, and what is the highest one? 2 power n. So your efficiency will be big O of 2 power n. Hence this proves that the efficiency of Tower of Hanoi algorithm is exponential, 2 power n, that is exponential. So thank you, this completes this video.